Okay, so once again, good morning everyone, and of course, thank you for attending our class. And so this will be our last meeting for prelim period, okay? And this will be also covered with our prelim exam this coming Thursday, hopefully that you are all available, okay? So the topic for today is about the IT infrastructure and emerging technologies. No? So after this lesson, we are able to answer the following questions. No, what is the IT infrastructure and what are components? No, what are its components? Now, what are the stages and technology drivers of IT infrastructure evolutions? So, what are the current trends in computer hardware platforms? What are the current trends in software platforms? And what are the challenges of managing IT infrastructure? So, as what we define in information technology on our first meeting, no, the IT infrastructure as the shared technology resources that provide the platform for the firm's specific information system applications. So IT infrastructure includes investment in hardware, software, and services, no, such as consulting, education, and training that are shared across the entire firm across entire business units in a firm. So a firm's IT infrastructure provides the foundation of serving customers, working with vendors, and managing internal firm business processes. So actually in other countries, specifically in US firms, no, with IT infrastructure, specifically for hardware and software, it's just in 2020 pa actually. So it is estimated to be a $1 trillion industry where telecommunications, network equipment or networking equipment and telecommunication services such as internet, telephone, and data transmission are included. So this does not include IT and related business process consulting services, which would add another $800 billion. So investment in infrastructure account for between 25 to 50% of information technology expenditures in large firms, led by financial services firms when IT investment is well over half of all capital investment. So we need to accept the fact that IT infrastructure consists of a set of physical devices and software applications that are required to operate the entire enterprise. No? But IT infrastructure is also a set of firm-wide services budgeted by management and comprising both human and technical capabilities. So for us to learn more about IT infrastructure and emerging technologies, let us all welcome Mr. Rafael. Go ahead.
Good morning. My name is Rafael Del Placido and I am reporting IT infrastructure and emerging technology. So first, we will discuss IT infrastructure. So what is IT infrastructure? Infrastructure is made of devices and all the hardware and software are required for the enterprises. We define IT infrastructure are set of devices and software required to operate enterprise. These infrastructure are required to run smoothly their businesses. So some infrastructure are composed of physical devices and software. This infrastructure have a set of firm-wide services including computing platforms providing computing services. Then they have telecommunication services which provides communication between customers and enterprises. Then they have data management where managing data centrally around the enterprise. And next we have application software which are required to compute the previous tasks in the enterprises. Then physical facilities management services that requires to run to the management in the enterprises. And the most important is IT management standards, education, research, and development services. And these are the important factors which is required to operate enterprise business. So this is the diagram of IT infrastructures and it defines all the IT services and infrastructure which compose of IT strategy, business strategy, and information technology. because because IT strategy and infrastructure, which is composed of all these factors, are interfacing each other around the world and all the types of businesses to run the enterprise. These are very important for enterprises to run their business smoothly. So, for the different eras, or we can easily say evolution for IT infrastructure, first, some computers which are connected to some system that there is no LAN, only 3 or 4 systems are managed equally. Evolution comes into the market and some systems are connected in the network where the business tasks are performed. Then all the systems and then all the services are connected to the internet where the people can share their businesses, tasks, other works around the world to the internet. And next is the things which are connected to internet are operated smoothly to run their infrastructures. These evolutions are increasing day by day to run the enterprises smoothly. So eras of IT infrastructure eras of IT infrastructure evolution is important at least these days. So this is the evolution of IT infrastructure. General purpose mainframe and mini computers era from 1959 to present. Some companies using mainframe and some small scale companies are using mini computers. Next, personal computer era, 1981 to present, where some entrepreneurs are using personal computers for their enterprises. Next is client server era from 1983 to present, where all the clients are connected to the server which are required for the business. Next is enterprise internet computing era, 1992 to present. Here, all the devices are connected to the internet for the enterprise business these days, and it represents from 1992 to present. And lastly, the cloud computing, 2000 until today, where different kind of data are stored on the cloud. This comes in year 2000 until today. All the enterprises are running in the business, and that's the evolution of IT infrastructure. Now, the next evolution comes with client server network or N-tier, where are the clients are connected to the internet and web server, application server, and main data server, which are the client can store their data to the internet to the server. This multi-tiered client server network or N-tier are very useful for the enterprises where a large data can be stored. So that's why most of the companies, enterprises, or utilize multi-tiered client server network for their smooth business. So that's why multi-tiered client server network are very important enterprise. Next is the technology drivers of infrastructure evolution. For the different laws which we apply for driving the infrastructure evolution, first is the Moore's law. Computing power doubles every 18 months. The microprocessing power are checked. Some powers doubles every year, mean the data are processing to the processors increasingly. Next, nanotechnology. May shrink size of transistors to width of several atoms. Next is contrary factors. Heat dissipation needs power of consumption concerns. And in the law of mass digital storage, where the amount of data being stored each year doubles. Next, this is the diagram in the figure which we analyze the technology drivers of infrastructure evolution. So we can see the increase of microprocessor of data, of which comes in Moore's law. The second figure, the technology driver, are also increasing as for the processing powers are increased. And in the third figure, some nanotechnologies are used to process the data in low wage. And this is the IT infrastructure evolution shown in the form of a graph. In the first diagram, the graph are increased as for the PC hard drive to store the data. In the second diagram also, where the data are processing to the data server. So this evolution are increasing day by day nowadays. For the components of IT infrastructure are computer hardware platforms, operating system platforms, enterprise software applications, data management and storage, networking telecommunication platforms, internet platforms, and consulting system integration services. These are all 7 infrastructure components which are required to run the enterprise systems. So this is the ecosystem of IT infrastructure. We have all the 7 types of ecosystems which require to run the enterprise where all the computer devices, hardware devices, physical devices, IT infrastructure, and human power. Everything are considered in IT infrastructure enterprises. So these ecosystems are built together to run the enterprise streams. So that's why infrastructure ecosystems are very, very important for the new generation and function system. That's all. Thank you.
Okay, so thank you very much. To add some, wag mo munang tanggalin yung ano. So to add some additional inputs related to his topic, no? So we need to consider some operation system platforms also, no? Like Unix, no, in Linux, which are capable and which are scalable, reliable, and much less expensive than mainframe operating system. They can also run on many different types of processors. No, the major providers of Unix operating system are IBM, HP, and Sun, and each with a slightly different and particular incompatible version. So we have the enterprise software applications now. Available, the ERP, no, at present, especially in the business today, no. So which cover the data management and storage, no, because enterprise database system or management system software is responsible for organizing and managing the firm's data so that they can efficiently access and use, no. So we have also the what we call SANs, no, the storage area network, no. It connects multiple storage devices on a separate high-speed network dedicated to storage. Now, the SAN creates a large central pool of storage that can be rapidly accessed and shared by multiple servers. Now, the networking telecommunication platforms is also covered. Now, considering the internet platforms, now the internet platforms overlap with and must relate to the firm's general networking infrastructure and hardware and software platform. No, of course, a web hosting service, no, maintaining a large web server or series of servers and provides fee-paying subscriber with space to maintain their website. So the internet revolutions created a veritable explosion in server computers with many firms now collecting thousands of small servers to run their internet operations. So since then, there has been a steady push toward server consolidation, reducing the number of server computers by increasing the size and power of each. No? So the major web software applications developed tools and suites are supplied by Microsoft Expression Web or SharePoint Designer and Microsoft.NET, no, family of development tools. Oracle, of course, Oracle, no, Oracle or Sans Java, and others. No, so consulting and system integration services. So today, even a large firm does not have the staff, the skill, the budget, or the necessary experience to deploy and maintain its entire IT infrastructure. So implementing a new infrastructure requires significant changes in business processes and procedures, training and education, and software integration. So leading consulting firms providing this expertise include Accenture, IBM Global Services, HP Enterprise Services, Infosys, and Wipro Technologies. Software integrations means ensuring the new infrastructure works with the firm's older, so-called legacy system, and ensuring that new system elements of the infrastructure work with one another. So the legacy systems are generally older transaction processing system created for mainframe computers that continue to be used to avoid the high cost of replacing or redesigning them. So replacing this system is cost prohibitive, no, and generally not necessary if this older system can be integrated into a contemporary infrastructure. So the contemporary hardware platform strengths, the exploding power of the computer hardware and network technology has dramatically changed. However, businesses organize their computing power, no, putting more of this power on networks and mobile handheld devices. So we look at 7 hardware trends, not the emerging mobile digital platform, the grid computing, virtualization, cloud computing, green computing, high performance power saving processor, and autonomic computing. So the emerging mobile digital platform, no, like cell phones and smartphones such as BlackBerry and iPhone have taken on many functions of handheld computers, including transmission of data, surfing the web, transmitting email and instant messages, no, displaying digital content, and exchanging data with internal corporate system. So the new mobile platform also includes small, low-cost, lightweight sub-notebooks called netbooks, no, optimized for wireless communication and internet access with core computing functions such as word processing, tablet computers such as the iPad, and digital ebook readers such as Amazon Kindle with some web access capabilities. In a few years, no, smartphones, netbooks, and tablet computers will be the primary means of accessing the internet. So with business computing moving increasingly from PCs and desktop machines, no, to these mobile devices. So for example, if the senior executives at General Motors are using smartphone applications that drill down into vehicle sales information, financial performance, manufacturing metrics, and project management status, at medical devices maker AstraTech, sales rep use their smartphones to access Salesforce.com, no, customer relationship management or the CRM applications, and sales data, checking data on sold and returned products, and overall revenue trends before meeting with customers. The grid computing, no, it involves connecting geographically remote computers into a single network to create a virtual supercomputer by combining the combinational power of all computers on the grid. So grid computing takes advantage of the fact that most computers use their central processing units on average only 25% of the time for the work they have been assigned, leaving these idle resources available for other processing tasks. Grid computing was impossible until high-speed internet connections enabled firms to connect remote machines economically and move enormous quantities of data. The grid computing requires software programs to control and allocate resources on the grid. So client software communication with the server software applications, and the server software applications breaks data and application code into chunks that are then parceled out to the grid's machine. And the client machine perform their traditional tasks while running grid applications in the background. Okay? The virtualization naman is the process of presenting a set of computing resources such as computing power of data storage, of course, so that they can all be accessed in ways that are not restricted by physical configurations or geographic location. So virtualization enables a single physical resource, no, such as server or storage device, to appear to the user as multiple logical resources. So for example, a server or mainframe can be configured to run many instances of an operating system so that it acts like many different machines. So virtualization also enables multiple physical resources such as storage devices or servers, to appear as single logical resources, as would be the case with the storage area, networks, or grid computing. So virtualization makes it possible for a company to handle its computer processing and the storage using computing resources housed in remote locations. So VMware is the leading virtualization software vendor for Windows and Linux server. So Microsoft opens its own virtual server product and has built virtualization capabilities into the newest version of Windows Server. Actually, there are some business benefits of virtualization. No? So by providing the ability to host multiple systems on a single physical machine, virtualization helps organization increase equipment utilization rates, conserving data center space and energy usage. And most servers run at just 15 to 20% of capacity. And virtualization can boost server utilization rates up to 70% or higher. So higher utilization rates translate into fewer computers required to process the same amount of work. So in addition to reducing hardware and power expenditure, virtualization allows business to run their legacy application on older version of an operating system on the same server as newer application. Virtualization also facilitates centralization and consolidation of hardware administration. It is now possible for companies and individuals to perform all of their computing works using a virtualized IT infrastructure, as is the case with cloud computing. Now, what is cloud computing? So cloud computing, we introduce cloud computing in which firms and individuals obtain computer processing, storage, software, and other services as a pool of virtualized resource over a network, no? Primarily the internet. So these resources are made available to users based on their needs, irrespective of their physical location or the location of the users themselves. So the U.S. National Institute of Standards and Technologies, or NIST, defines cloud computing as having the essential characteristic: on-demand self-service, ubiquitous network access, location-independent resource pooling, rapid elasticity, and measured services. Cloud computing consists of three different types of services. We have the cloud infrastructure as service. No? We have the cloud platform as a service, and we have cloud software as a service. A cloud can be private or public. So a public cloud is maintained by an external service provider, such as Amazon Web Services, accessed through the internet and available to the general public. A private cloud is a proprietary network or a data center that ties together servers, storage, networks, data, and application as a set of virtualized services that are shared by user inside a company. So like public clouds, private clouds are able to allocate storage, computing power, or other resources seamlessly to provide computing resources on an as-needed basis. So financial institutions and healthcare providers are likely to gravitate toward private clouds because these organizations handle so much sensitive financial and personal information. So since organizations using cloud computing generally do not own the infrastructure, they do not have to make a large investment in their own hardware and software. Instead, they purchase their computing services from remote providers and pay only for the amount of computing power they actually use, or the called utility computing, or are billed on a monthly or annual subscription basis. The term on-demand computing has also been used to describe such services. Okay? So cloud computing has drawbacks also. Unless user make provision for storing their data logically, so the responsibility of data storage and control is in the hands of the providers. So some companies worry about the security risk related to entrusting their critical data and systems to an outside vendor that also works with other companies. And there are also questions of system reliability. No? Companies expect their system to be available 24/7 and do not want to suffer any loss of business capability if their IT infrastructure malfunctions. So there are some who believe that cloud computing represents a sea change in the way computing will be performed by corporation as business computing shifts out of private data centers into cloud servers. So this remains a matter of debate because cloud computing is more immediately appealing to small and medium-sized businesses that lack resources to purchase and own their own hardware and software. But however, large corporations have huge investment in complex proprietary systems support unique business processes, some of which give them strategic advantage. So for them, the most likely scenario is a hybrid computing model where firms use their own infrastructure for their most essential core activities and adopt public cloud computing for less critical system or for additional processing capacity during peak business periods. So cloud computing will gradually shift firms from having a fixed infrastructure capacity toward a more flexible infrastructure, some of it owned by the firm and some of it rented from giant computer centers owned by computer hardware vendors. So how about the green computing? No? By curbing hardware proliferation and power consumption, virtualization has become one of the principal technologies for promoting green computing. So green computing or green IT refers to practices and technologies for designing, manufacturing, using and disposing of computer servers and associated devices such as monitors, printers, storage devices, and networking and communication system to minimize impact on the environment. So reducing computer power consumption has been a very high green priority. So as companies deploy hundreds or thousands of servers, many are spending almost as much on electricity to power and cool their system as they grid on purchasing the hardware. Okay? Another is the autonomic computing. The autonomic computing with a large system encompassing many thousands of network devices, computer system had become so complex today that some experts believe that they may not be manageable in the future. So one approach to dealing with this problem is to employ autonomic computing. So autonomic computing is an industry-wide effort to develop systems that can configure themselves, optimize and tune themselves, heal themselves when broken, and protect themselves from outside intruders and self-destruction. And you can glimpse a few of these capabilities in desktop systems. So for instance, virus and firewall protection software are able to detect viruses on PCs, automatically defeat the viruses and alert operators. And these programs can be updated automatically as the need arises by connecting to an online virus protection services such as Mashup Apps. IBM and other vendors are starting to build autonomy features into products of large system. So the high performance and power saving processors. So another way to reduce power requirements and hardware sprawl is to use more efficient and more power saving processors. Contemporary microprocessors now feature multiprocessor cores now on a single chip, which perform the reading and execution of computer instruction. A multi-core processor is an integrated circuit to which two or more processor cores had been attached for enhanced performance, reduced power consumption, and more efficient simultaneously processing of multiple tasks. So if you wanted to buy your own computer, try to consider the multi-core processor because this technology enables two or more processing engines with reduced power requirements and heat dissipation to perform tasks faster than a resource-hungry chip with a single processing core. So today, you'll find dual-core and quad-core processor in PCs and servers with 8, 10, 12, and 16-core processor. So Intel and other chip manufacturers have also developed microprocessor that minimize power consumption. So low power consumption is essential for prolonging battery life in smartphones, netbooks, and other mobile digital devices. So you will find now highly power efficient microprocessors such as ARM, Apple's A4 processors, and Intel Atom in netbooks, digital media players in smartphones. So the A4 processor used in the latest version of the iPhone and the iPad consumes approximately 500 to 800 milliwatts of power, about 1/50 or 1/30 the power consumption of laptop dual core processor. So To summarize the discussion, actually before that, before I forgot, we have a contemporary software platform trends. The Linux in open source software, Java in Ajax, web services and service-oriented architecture, and the software outsourcing and cloud services. So, open source software is software produced by a community of several thousands programmers. So, according to the leading open source professional association, opensource.org or open source software is free and can be modified by users. So works derived from the original code must also be free, and the software can be redistributed by the user without additional licensing. An open source software is by definition not restricted by the specific operating system or hardware technology. Although most open source software is currently based on Linux or Unix operating system. The open source movement has been evolving for more than 30 years and has demonstrated that it can produce commercially acceptable, high-quality software. Popular open source software tools include the Linux operating system, the Apache HTTP web server, the Mozilla Firefox web server, and the Oracle OpenOffice desktop productivity suite. Open source tools are being used on netbooks as inexpensive alternatives to Microsoft Office. So major hardware and software vendors, including IBM, HP, Dell, Oracle, and SAP, now offer Linux-compatible version of their products. So you can find out more about the open source definitions from the open source initiative in the history of open source software at the learning tracks of this discussion. So Linux, perhaps the most well-known open source software is Linux. Now, an operating system related to Unix. Linux was created by the Finnish programmer Linus Torvalds and first posted at the internal in August 1991. So Linux applications are embedded in cell phones, smartphones, netbooks, and consumer electronics. Linux is available in free version, downloadable from internet, and a low-cost commercial version that include tools and support from vendors such as Red Hat. The software for the web, Java and Ajax. No? Again, Java is an operating system independent, no processor independent, object-oriented language that has become the leading interactive environment for the web. Java was created by James Gosling and the Green team of Sun Microsystem in 1992. No, the Java platform has migrated into cellular phones, smartphones, automobiles, music players, game machine, and finally into set-top cable television system serving interactive content and pay-per-view services. Java software is designed to run on any computer or computing devices. No? So Java developers can create small applet programs that can be embedded in the web pages and downloaded to run a web server. So a web server is a pages or for accessing the web and other internet browsers, no, or resources. So like Microsoft Edge, no, right now Microsoft Edge. Now we have Google Chrome and others. Firefox, Mozilla, no, and others. On the other hand, no, Ajax, have you ever filled out a web order form? No, made a mistake and then had to start all over again after a long wait for a new order form page to appear on your computer screen. So Ajax, no, stands for Asynchronous JavaScript in XML, is another web development technique for creating interactive web applications that prevents all of this inconvenience. Ajax allows a client and server to exchange a small piece of data behind the scene so that an entire web page does not have to be reloaded each time the user requests a change. So if you click a north on a map site such as Google Maps, the server downloads just the part of the applications that changes with no wait for an entire new map. So you can also grab maps in map application and move the map in any directions without forcing a reload of the entire page. Ajax uses JavaScript program downloaded to your client to maintain a near continuous conversations with the server you are using, making the user experience more seamless. Again, Ajax stands for asynchronous, JavaScript, and XML. Now, how about the web services and service-oriented architecture? So web services refers to a set of loosely coupled software components that exchange information with each other using universal web communication standards and languages. They can exchange information between two different systems regardless of the operating system or programming language on which the system are based. So they can be used to build open standard web-based application linking systems of two different organizations, and they can also be used to create applications that link disparate system within a single company. So web services are not tied to any operating system or programming language, and different application can use them to communicate with each other in a standard way without time-consuming custom coding. So the foundation technology of web service is XML. XML stands for Extensible Markup Language. No? This language was developed in 1996 by the World Wide Web Consortium. No? Another is Hypertext Markup Language, or the HTML. No? This is the page description language for specifying how text, graphics, video, and sounds are placed on a web page document. So the collection of web services that are used to build a firm software system constitute what is known as the service-oriented architecture. So the SOA is a set of self-contained services that communicate with each other to create a working software application. So business tasks are accomplished by executing a series of these services, and software developers reuse these services in other combination of assemble other applications. So software outsourcing in cloud services. Today, many business firms continues to operate legacy systems that continue to meet a business need and that would be extremely costly to replace. But they will purchase or rent most of their new software applications from external sources. So we have software package. No? Software package is a pre-written commercially available set of software programs that eliminates the need to a firm to write its own software programs for certain functions such as payroll system or order handling. So enterprise application software vendors such as SAP and Oracle PeopleSoft have developed powerful software packages that can support the primary business processes of a firms, widely from warehousing, customer relationship management, supply chain management, and finance to human resources. This large-scale enterprise software system provide a single integrated worldwide software system for firms at cost much less than they should pay if they develop it themselves. Okay? So the software outsourcing. The software outsourcing enables a firm to contract custom software development or maintenance of existing legacy programs outside firms. So which often operate offshore in low wage areas of the world. Okay. So offshore outsourcing firms have primarily provided lower level maintenance, so data entry and call center operations. However, with the growing sophistication and experience of offshore firms, particularly in India, more and more new program development is taking place offshore. Okay, so cloud-based software services and tools. In the past, software such as Microsoft Word or Adobe Illustrator came in a box and it was designed to operate on a single machine. Today, you're more likely to download the software from the vendor's website or to use the software as a cloud service delivered over the internet. No? Cloud-based software and the data it uses are hosted on powerful server in massive data centers and can be accessed with the internet connections in standard web browser. Okay? So we have also what we call software as a service, no? As what we discussed a while ago. Again, we need also to familiar with the order to manage the relationship with customer outsourcers or technology service provider. The firm need to contract that includes service level agreement, the SLA. So the SLA is formal contract between customers and their service providers that defines the specific responsibility of the server provider and the level of service expected by the customer. So SLAs or service level agreement typically specify the nature and level of services provided. So criteria performance measurement, support options, provisions for security and disaster recovery, hardware and software ownership and upgrades, customer service support, billing, conditions for terminating the agreement, and of course, that is under service level agreement. Another thing is the mashup and apps. No? The software you use for both personal and business tasks may consist of large self-contained programs, or it may be composed of interchangeable components that integrate freely with other applications on the internet. Individual users and entire companies mix and match these software components to create their own customized application and to share informations with others. So the resulting software applications are called mashups. No? The idea is to take different sources and produce a new work that is greater than. So the sum of its parts. Okay, you have performed a mashup if you ever personalize your Facebook profile or your blog with a capacity or capability to display videos or slideshows. Apps are small pieces of software that runs on the internet on your computer or on your cell phone and are generally delivered over the internet. So actually, we have a management issue, no, the scalability, no, which refers to the ability of computer, product, or system to expand the server or serve a larger number of users without breaking down. Because new applications, mergers, and acquisitions, and change in the business volume will impact computer workload and must be considered when planning hardware capability. And IT infrastructure, making wise infrastructure investment, no? It is the major investment for the firm. So if too much is spent on infrastructure, it lies idle and constitute a drag on firm financial performance. So cloud computing may be a low-cost way to increase scalability and flexibility, but firms should evaluate this option carefully in light of security requirements and impact on business processes and workflows. In some instances, the cost of printing software adds up to more than purchasing and maintaining the application in-house. Yet, there may be benefits to using SaaS or SaaS if it allows the company to focus on core business and issues instead of technological changes. The total cost of ownership model can be used to analyze this direct and indirect costs to help firms determine the actual cost of specific components to technology implementations. So, of course, when it comes to competitive forces model for IT infrastructure investment, we have the market demand for your firm's services, your firm's business strategy, your firm's IT strategy, infrastructure and cost, and information technology assistance. So we consider the competitor firm services and the competitor firm IT infrastructure investment. Now, a while ago, we asked what is IT infrastructure and what are its components, no? Again, to summarize, no, IT infrastructure is the shared technology resources that provide the platform for the firm's specific information system applications. So IT infrastructure include hardware, software, and services that are shared across the entire firm. The IT infrastructure components include computer hardware platforms, operating system platforms, enterprise software app platforms, network and telecommunication platforms, and database management software, internet platforms, and consulting services and system integrations. So what are the stages and technology drivers of IT infrastructure solution evolutions? The 5 stages IT infrastructure evolutions are the mainframe era, the personal computer era, the client server era, the enterprise computing era, and the cloud and mobile computing era. Moore's law deals with the exponential increase in processing power and decline in the cost of computer technology, stating that every 18 months the power of microprocessor doubles and the price of computing falls in half. Okay, so also driving exploding computer use in the rapid decline is cost of communication and growing agreement in the technology industry to use the computing and communication standard. So what are the current trends in computer hardware platforms? Increasing computing is taking place on a mobile digital platform. So grid computing involves connecting geographical remote computers into a single network to create a computational grid that combines the computing power of all the computers on the network. Virtualization organizes computing resources so that their use is not restricted by physical configurations or geographic locations. In cloud computing, the firms and individuals obtain computing power and software as services over a network, including the internet, rather than purchasing and installing the hardware and software on their own computers. A multi-core processor is a microprocessor to which 2 or more processing cores have been attached for enhanced performance. Green computing includes practices and technologies for producing, using, and disposing of information technology hardware to minimize negative impact on the environment. And autonomic computing, computer systems have capabilities for automatically configuring and repairing themselves. Of course, power-saving processor dramatically reduce power consumptions in mobile digital devices. So what are the current trends in software platforms? No? Open source software is produced and maintained by a global community of programmers and is open downloadable for free. Linux is a powerful, resilient open source operating system that can run on multiple hardware platforms and used widely to run web server. Java is an operating system and hardware independent programming language that is the leading interactive programming environment for the web. So web services are loosely coupled software components based on the open web standards that works with an application software and operating system. They can be used as components of web-based application, linking the system of 2 different organizations or to link disparate system of a single company. Companies are purchasing their new software applications from outside sources, including software packages by outsourcing customer application development to an external vendor that may be offshore, or by renting online software services. Mashup combine 2 different software services to create new software application and services. Apps are small pieces of software that turn on the internet, that run on the internet on a computer or on a mobile phone and are generally delivered over the internet. So what are the challenges of managing IT infrastructure and management? Major challenges include dealing with platform and infrastructure change, no? Infrastructure management and governance and making wise infrastructure investment. Solution guidelines include using a competitive courses model to determine how much to spend on IT infrastructure and where to make a strategic infrastructure investment, and establishing the total cost of ownership on information technology assets. So the total cost of owning technology resources include not only the original cost of computer hardware and software, but also cost of hardware and software upgrades, maintenance, technical support, and training. So I think that's it for this topic. So thank you.